Hello and welcome to another episode of Undercooled. Today we have a great guest, a good friend of mine, Professor Rob Beck from the Anthropology Department. Rob is an archaeologist, and I've known Rob ever since we started teaching this course called Making Things, 3 million years of materials and culture. And it has been a blast. I've learned a lot, and I've come to learn we can learn quite a bit about materials, about their uses, about their evolution, and even about sustainability by studying archaeology. And so, Rob, welcome.
Thank you.
I'm really glad you're here.
Good to be here.
So let's start where we always start. Who are you? Tell us, who is Rob Beck? How did you get to your career arc? So let's hear it.
Okay, how far back does the career arc kind of stuff go? Back when I'm from North Carolina, and I grew up in a small town about 30 miles east of Asheville, right off of Interstate 40. And I think if anyone had asked me when I was 6 or 7 years old what I was going to be when I grew up, I'd have said archaeologist. And in fact, one of my earliest childhood memories was being in the Kmart at Christmas time with my mom and dad. And they had a book in Kmart called the LaRousse Encyclopedia of Archaeology. And I really wanted that book. And I actually, one of the few times my mom would have agreed with this, one of the few times in my childhood when I actually pitched a tantrum anywhere was that they would not buy me that LaRousse Encyclopedia of Archaeology on that Friday night. But they had already bought a copy for Santa Claus to give me, and they weren't going to buy 2 copies of it. So I still have that LaRousse on my shelf in my office. So I grew up just fascinated with archaeology. I had aunts and uncles who had farms in that part of the North Carolina foothills, and they would find arrowheads when they plowed. They would find other kinds of artifacts when they plowed. When I got to be a little bit older, I'd go walk behind the plows. Eventually, my mom and dad would drop me off in a field on their way to do errands in town. They'd drop me off in a field in town, and I was already making collections from the sites and labeling things from different sites, keeping things from different sites in different shoeboxes. Eventually, I made my way to North Carolina, Chapel Hill. Got my BA there, and ended up majoring in political science for whatever reason a 22-year-old makes decisions. But the whole time I was there, I was working as a volunteer, then paid employee in the archaeology laboratory. I did public archaeology, contract archaeology for 2 to 3 years after I graduated college. Went to the University of Alabama, got my master's degree, got into Northwestern for the PhD. And did my dissertation in the Andes of Bolivia, in the Titicaca Basin, and ended up getting a first job at the University of Oklahoma, and was there for 3.5 years before coming to Michigan in 2000, started in January 2010.
Wow, that's pretty cool. So I guess that's a very well-accepted way to do archaeology, get a plow ahead of you and walk behind.
Oh, it's a great way to start. It's a great way to start. And as it turns out that those skills, and I call them skills, I picked up, as a 6, 7, 8-year-old, that's a lot of archaeology is we try to do it in a more systematic way, but doing surface collections of sites and mapping what you find and, different contexts. You're going to map each artifact as you find it. Other times you're just going to map the distribution of artifacts in that field. And yeah. I was doing it as a second grader.
I hear you even go back to the Spanish Fort.
Oh, yeah.
It was around the corner from where you grew up, probably.
Yep. So I did my dissertation in the Andes, but I had done my master's thesis in North Carolina, near where I was from. And after getting the PhD, I tried for a while to pitch myself as both an Andeanist and a East North American archaeologist simultaneously, which is tough to do as a junior faculty member. Job committees don't really tend to take you very seriously with that. So I did some soul searching and realized that, and I still think I was correct, that if any of the search committees have been looking for an Andean archaeologist, they're always going to find a better Andeanist than me. So I switched over to my first love, which was Eastern North America. And fortunately, a site that I had been working on since I was young, I had gone back there, did a collection as part of my master's degree. Turns out there's a Spanish fort there. And the Spanish fort was Fort San Juan, which was actually built and established on Christmas Eve, December 24th, 1566, by Captain Juan Pardo, coming out of the main Spanish colony, which is on Paris Island, actually under the Marine officers' golf course on modern-day Paris Island. So he went in to basically establish a road from the Spanish colony in the Atlantic, ideally to Mexico. They really thought that the Appalachian Mountains and the Rocky Mountains were the same thing. And the idea was that when he crossed the Appalachians, that Mexico would only be another week or two hike away. So they made it as far as this site and built a fort there, left 30 guys. And the 30 soldiers were in the middle of a Native American town called Jawara. Jawara was the most important kind of political group in that part of the Carolina foothills. And the fort lasted for a year and a half before the Native Americans at Jawara got tired of basically sustaining these Spaniards, and they burned the fort down, killed the soldiers. And so what we have been excavating for the last quarter century or so is the remains of the fort, the 5 houses where the Spaniards were living. We're now working in a couple of the buildings where the Native American people were living, and basically looking at how this relationship unfolded and then came apart in the span of about 18 months.
All right. Well, before we get into more specialized matters, there's a baseline question which has to be asked, which is, as we all know, the word archaeology is Greek, archaeologia, and archaeos is like the primeval times, right?
Yes.
But how do you spell archaeology in English? Because Steve and I have a disagreement.
I spell it with the AE.
Okay.
So I use the Greek, and now there are some places in archaeology that have shifted more to just spelling with the E and dropping the A. But I'm an archaeologist. I like the old stuff.
All right, we're aligned. We can move forward with the conversation. Great.
Our show notes will be correct.
Great. So in terms of your area of expertise then, this is still your active research project? Is you're working on that area?
Yep, I am still actively working on that area with a team. There are, 4 or 5 of us now. It started out with just 3 of us, but one of us is just retired. Dave Moore's just retired from Warren Wilson College. I've also got a colleague at Tulane University. I've got a colleague at UNC Chapel Hill, and a colleague who's just starting at University of Georgia this fall. So the now 5 of us, 2 of our colleagues, our younger colleagues, did dissertations in the general theme of things. But since 2020 or so, I've also been doing a second project, which in some ways has become equal, if not primary for the moment at least. I'm doing a geophysical survey at the site of Cahokia. So Cahokia is the largest Native American site north of the Valley of Mexico. It covered something like 5 to 6 square kilometers at its peak. And I'm working with a team, Colorado State, Bryn Mawr College, and we are doing a complete magnetometer survey of the site of Cahokia. To this point, we've covered about 5 square kilometers. And it basically gives us an X-ray of what's there without putting a single hole in the ground. We have the area we've covered. The only survey that we've been able to find in the world that's larger than this one is the survey of the Salisbury Plain in England, which is where Stonehenge is located. So it's a massive survey. We're going to end up with something like 1.5 billion data points. And we are literally able to see every house, every pit, and we can map where all the different neighborhoods are at, where the different communities are at. And this is a place that archaeologists have recently come to think of as a city, as an urban location. And so it's one of the few places in the world like it where we can get this kind of resolution because it's all open field and prairie. And we can just basically pull our machines behind ATVs.
So that's really fascinating how these magnetometers even work.
Yeah.
So these things what are the size of them? They're like 3 feet tall?
Yeah, yep. So it's about 3 feet tall, and the original magnetometers that archaeologists were carrying around 30 years or so ago were a single rod. And you've got a sensor at the top and a sensor at the bottom. And the sensor at the top is basically keeping track of the Earth's the background magnetic variation, and the sensor at the bottom is sending the signal into the ground. And so anytime there's an anomaly, anytime that signal coming out of the ground picks up an orientation that's not the same as the background, it registers it as such. So, but again, 30 years ago, you're carrying a single rod around. It takes a while to cover a big site. But now these rigs exist. Two of my colleagues on this Cahokia project have these rigs that have 18 sensors, 16 or 18 sensors in a row in a single rig. And so with those, you hook it up to an ATV and you drive it.
Right.
Yeah.
Wow.
And they're pretty sensitive because
Very.
you're able to detect things that aren't ferromagnetic.
Exactly.
So you can see paramagnetic materials
Yes.
or diamagnetic materials. And so I remember you showed the class some of the things from the Spanish fort, and you have resolution where you can see a 4x4 post
Yes.
where the content of the decomposed wood in the ground gave you contrast, and you could see every corner.
Yeah, and we even have resolution with the survey we're doing now. We have a resolution of less than a centimeter. Wow. I could put a soil core this big around into the ground and come down basically within the 1 or 2 square centimeter square that I'm trying to place it in.
That's amazing. Yeah. This is why when I saw that talk you gave, I went to Tim, who was running our lab, and said, Tim, we need to build a lab where we use magnetometers as a materials characterization technique.
Well, one of the other great things about it is that we don't even have to lay out transect lines and things now. We go to one of the high mounds and set up an antenna and our GIS unit, and each of the rigs has a GIS unit on it. They communicate with each other. You can basically take the map you create and plop it into a GIS of the American bottom of North America, and again, you're down to within a centimeter of accuracy. It's fantastic. It's science.
Yeah, that's crazy. That's awesome. So besides you being a practicing archaeologist and having all this fun, you remind me of geologists. I was on a geology committee, and they were so lucky. They spent every summer camping. And then they come back during the winter and analyze their data. But they'd bring their canoes and go in mountainous regions and collect rocks. Well, you kind of do the same thing, but you're collecting artifacts, and then you also come back and then analyze it all when you get back here. So it's.
Although my wife would laugh about the camping part of it because I refused to camp. Because my entire dissertation, I spent a year in Bolivia living on fish meal, straw stuffed fish meal bags with my sleeping bag. And when I came back, I said, I'm done. I value my back too much.
Yep, I can understand that. But you've ended up in a very different role since you've been in Michigan with this archaeology museum.
Yes.
Can you tell us what it even is? Most people think the Archaeology Museum at Michigan is that building on State Street, the Kelsey Anthropology Museum.
Yeah. So the Kelsey Museum is a museum of classical archaeology. And it's a lot of what people think of as archaeology, because you go to the Kelsey, you see Greek artifacts, you see Roman artifacts, you'll see some Egyptian artifacts, maybe some Mesopotamian artifacts. And the Kelsey is very much focused on that part of the kind of that broader Mediterranean world that is in so many ways the roots of a lot of Western Civ. And it is what a lot of people think of archaeology. And it's classical archaeology because it's associated with classics, and it's also all text, at least text affiliate, if not text based. And what you do with the kind of materials at the Kelsey, you learn about life in ancient Rome. You learn about life in ancient Greece during the Ptolemaic period, which is fantastic. That's what a lot of archaeology is. I'm in the Museum of Anthropological Archaeology, which is a mouthful. We call it UMA, but it's UMA with an extra A, because the Art Museum is also UMA. Yeah, so we're UMA. And so in UMA, again, we're coming at it from anthropology rather than coming at it from classics. So the kind of archaeology that I do, that I'm interested in, always comes back to different kinds of key big ideas. And the biggest of all, in a way, and I think what is at the heart of anthropological archaeology, it's not about what life looked like at any particular point in time in the past. The point is to ask the question of, why does the world look the way it does today? Why does the cultural world that we live in look the way it does today? That means we're looking at things like urbanism. We're looking at the rise of inequality. We're looking at domestication. All of these things that are part of our everyday world that we completely take for granted, but that we can't understand our everyday world without having a sense of. And our museum is, the Kelsey Museum has a couple 100,000 artifacts. Our museum has more than 3 million artifacts from something like 51 countries, all 50 states, every continent except Antarctica. And it's a research museum. So there's not an exhibit, you'll see with UMA. We are a museum where people come from around the world to do analysis with the collections that we have there. And actually, we've just learned that we are going to be moving into a permanent facility on Varsity Drive. We're going to have a permanent archaeology, a center for world archaeology, basically. So we're in the process of working through the college to get it all off the ground here in the next couple of years.
Well, it's very exciting.
Yeah,
will there be public access, or will it be researchers only?
It will be primarily research, but we're hoping to have some exhibit space in there as well.
That's excellent. Yeah. Something that I think about a lot as an engineering instructor is the importance of sociological questions. Very much the why is the world the way it is, but especially for our students who are going to be going out in the world and, pun intended, making things. Yeah. But they're making things for people, as people. Yep. And if they're not thinking about the humans in the equation, they're doing bad engineering, is my take.
Great. Yeah, that's a great way of thinking about it.
So with these sorts of questions of what makes us all human, I mean, we just jump right into the big thing. I know one of the areas that Steve and I have talked about is the idea of transfer, right? That humans, in all the ways that we keep being, humans are special, and we discover, oh, humans are not special. As we learn more about non-human animals, it seems like this habit that we have of building models of the world and then adapting them to new situations seems to be a really core human trait. So can you talk a little about that?
Absolutely. I remember reading, actually I would recommend anyone. I don't necessarily always recommend sociology or those, because it can be fairly dense stuff if you're not a sociologist. Sometimes it seems like it's just obfuscating. But there's a scholar named, a sociologist named William Sewell. It's actually William Sewell Jr. And he wrote a book called The Logics of History. Now, and part of the book is, it does bring together also some articles that he had read previously, but I would that he had written previously. But I would recommend The Logics of History. He talks about the idea of transposing. And the way he defines transposing is our capacity. And he defines it as a capacity. We don't always do it all the time, but every human has the capacity to do it. And it's the capacity to take something, a schema, a rule, an operation that we've learned in one context and to apply it to something completely different. No other animal does that. Not that we can see. And I think that's the key of technology. Sewell defines it as the definition of agency. He defines agency as the capacity to transpose.
Interesting.
Right. So he considers it that core part of our human mind, basically, of our humanness. And I would say, along with that I think it's the key to human technology. And I try to be pretty careful with how I define technology. Lots of animals use tools. Which is basically, you can use a stick. You see ants. You see even like gorillas will take a stick and peel the bark off and put it in ants' nest and then lick the ants off.
Right, or octopi using seashells.
Exactly, an otter using a rock to smash a shell open. But technology is something different. I think of technology as basically the capacity to use two or more tools together that accomplish something that either one of them by themselves couldn't do, which is a very different way of thinking about it. And in a way, the simplest way of thinking about it, I think the simplest form of tool is the hammer and the anvil, right? So that if you imagine the hammer stone and the flat anvil, and you put a nut on there and you smack it, and you break the nut, and you get the meat of the nut out to eat it. If you imagine trying to do that without either one of those two things, if you take the hammer or the hammer stone and put the nut on the ground and smack it, you just bury the nut in the ground. If you put it on the anvil and smash it with your fist, you just break your hand. So it really requires those two things together. And the only two animals on the planet we know of who use that simplest form of technology are those in our line, Homo sapiens sapien, and some primates like chimpanzees. And I think there's also a primate in South America that has been documented doing that. So it's part of our primate heritage, this capacity. Now, that's different than transposing, but that it all starts from there.
Sure.
Right.
Yeah, it's really fascinating because I don't think we teach this when we teach engineers.
Yeah.
And I think we probably should, because in a way, what you just described is why it's important for our students to learn physics. Because physics is very general, and then we apply it in many, many different ways, and we're doing something that's very, very human.
Yeah.
I once heard it's funny, this is since I've heard you talk about this, I kept my mouth shut, but this executive was saying that the thing engineers do uniquely is they have this idea of transference, and that's what engineers do. People in the financial world and managers, they never know how to do this. And it's like, no, you just don't understand financial and other. They are doing it because the very fact that they're using Microsoft Excel to apply spreadsheets to all these different situations is a perfect example of transference.
Or the different kinds of funds you set up for this tax break. That's all transposing.
That's right. Making categories and so, the mathematician in me, because I was a math major as an undergrad, thinks it's even more basic than that. And I'd say it's the ability for humans to have abstract thoughts. So, what does this phone and this microphone have in common? There's one of each of them. That had to be the first abstract thought. But that is transference in, capital letters. Yeah. And so the very concept of number and any abstract thought is another example of transference. Yeah. And then I told you the story of my friend Gerard Moreau, who won the Nobel Prize in Physics by taking an idea that he read about in the World War II era of radar and applying it to lasers using chirp pulse amplification that ended up winning him a Nobel Prize.
Yep, that's transposing. I mean, you guys call it transference, we call it transposing. It's the same thing. It's the same idea. Yeah.
We even call a mathematical operation the transpose of a matrix.
Okay. That's enough of that.
Got to draw the line somewhere.
That's right.
So another really cool thing that I learned from teaching the course with you was when you showed the class that book, I forgot the title, but it was all about cooking, making food.
Oh, yeah.
What was that book?
Richard Wrangham. The book is called Catching Fire, I believe. And it's Richard Wrangham's cooking hypothesis.
Because that's another thing humans did and nobody else did.
As far as we know, not a single other animal in the history of life on Earth has cooked their food intentionally. Now, obviously, you may have a carnivore that comes to an area where there's been a wildfire and accidentally, or not inadvertently, eats partially cooked animal that didn't get out of the fire. And undoubtedly, that's how our ancestors ate cooked food for the first time. Totally, it was what was there, what was available. But the cooking hypothesis itself is really interesting. The idea is that cooking is a form of pre-digestion. So it is really expensive in terms of calories and energy to digest your food. That's one of the reasons that as you go back farther and farther through time, you get back to 1.5 million years, 2 million, 2.5 million years. Our hominid ancestors had big jaws and great big molars and teeth because they spent so much time working to chew their food. Wrangham actually estimates that chimpanzees today spend an average of 6 hours a day chewing. And you have to be able to chew that stuff down to such a degree for your stomach to be able to process it. And even then, you need a very long intestinal tract to be able to absorb what the stomach is processing. Cooking changes all that. Cooking is a form of pre-digestion. It actually makes that food more ready to absorb in the intestinal lining, makes it easier for the stomach to break down. So Wrangham's idea is that once we start eating cooked food, this doesn't even mean controlling fire. We don't have to be controlling fire to use fire. There's this fantastic shot. I can't remember what the movie is, but it's a shot at the very opening of the film where you see some kind of hominid. It's not clear if it's a Neanderthal or maybe Homo erectus, but they've got furs and stuff covering them, and they're walking in this really snowy landscape, and they're carrying in their hands this organic mat that has a little flame growing in it. And they're trying to carry it to the next place. This person can't make fire, but they've collected it and they're trying to get it back to that camp place, that rock shelter or cave, so that they can actually use it there for warmth and cooking the food. So anyway, Wrangham's idea is that once we start cooking food and pre-digesting it, that all of that energy that was going into the digestive tract, that was going into big molars, that was going into big jaws, that energy gets diverted up here. And so that it all goes into brain growth and brain expansion. And once we are controlling fire and we have hearths, well, then you've got people can gather around it at night. People can cook. Really having something like a hearth at night is the only way that a hominid can sleep on the ground at night safely. Otherwise you're still going up in trees to sleep. Right? So it changes everything. It increases communication. What do people do around fires at night? After you cook, what do you do?
Around, talk,
you talk, you sing, you tell stories. All right. The whole narrative, the whole idea of narrative may have come out of those conversations. Right. So it's a fantastic hypothesis.
So just a week or so ago, I happened to come across a news article about a recent discovery in Britain, which was independent of us preparing this episode, funny enough. And so there was this discovery of what seems to be the remains of a hearth, as well as some flint and pyrite fire-making kit from 400,000 years ago. So this is before anatomically modern humans. Exactly. So what's your take on all that?
I think it's very exciting. There's one of the problems with this, with the Wrangham's hypothesis, it's not actually a problem with the hypothesis. It's a problem with operationalizing it. The hypothesis is that how do you prove it? Where do the data come from? Finding organic materials or things like hearths from that age, the farther you go back, the harder and harder it is to find things that are preserved from the archaeological record. That's one of the reasons we call it the Stone Age, because the stone's what's preserved. But we know people were using lots of organic things that we just don't have as you go back farther. So the idea that our cousins were like Neanderthal, were somehow beneath us, that went out the window a long time ago. We now see just how closely related we are to Neanderthal, close enough that we weren't even separate species. And we know we weren't separate species because all of us of, in other words, any kind of European descent have somewhere between 1 to 2, maybe 3% of our DNA is from the Neanderthal genome. So we know there are a couple of times between 25,000 and 45,000 years or so ago when our anatomically modern human ancestors successfully had viable offspring with Neanderthal. So we're very close. And so the idea that Neanderthal had hearths and actually could control fire. You don't have hearths like that that are used. One of the coolest things about that hearth is not just that it was a one-time thing, but that particular area had been reused as a hearth over and over and over and over again, maybe for centuries. And that's an indication that these people could control fire and continually rebuild the fire in the same spot whenever they were in that area. So the fact that this is actually some good evidence in favor of Wrangham's hypothesis, that in order for cooking to have this effect on our on our brain growth and the increasing brain size, it can't be something that happened for the first time 150,000 years ago, 200,000 years ago. It had to have happened 1,000,000 years ago. So pushing this back to 400,000 years is it's good archaeology, and it's a great case.
And I imagine that, your error bar on that is probably plus or minus 300,000 years.
Yeah.
But it means it probably happened much earlier. We just haven't found it.
Exactly. We haven't found those hearths yet.
So,
and the other thing to keep in mind is just how small the populations were. So the entire population, this sounds crazy, but all the estimates suggest that around 25,000 years ago, by which point humans had been in Europe for 20,000 years, the entire Homo sapiens sapien population of Europe was probably not more than 5,000 to 10,000 people. And there were fewer Neanderthals. So if we're talking about populations that small, finding something like a site like this, a hearth like that, it's literally needle in a haystack.
wow. Yeah. That's amazing. Man.
Scale is everything.
But it also relates to many things that we talked about. So we should probably talk about our course a little bit.
Yeah.
So, I had seen what Kevin Jones had done at Florida with the Sociology department about the impact of materials on society. So I figured I didn't really want to talk to the sociologists. I thought anthropology was much more interesting. So I talked to the chair of anthropology and asked, is this something any of you would be interested in? He said, the archaeologists would love this. And they brought me immediately to Mike. And he does, metal objects from the Balkan region. And of course, when I was telling him about our undergraduate lab, he started drooling because we have the kind of characterization equipment that he'd love to use. And he still can use it. Yeah. He just needs to talk to
We should do more of that, yeah.
And but he said he knows the perfect person who would want to teach the course. And of course, that was you. So we started teaching it, not knowing what we were doing. And then we got thrown quite a loop because the pandemic happened. Started. And so the very first offering and all of our meetings were all done on Zoom.
All on Zoom.
And Kevin Jones was very helpful. He gave us all his materials, but we quickly realized that we could use that as a template, but we had to redo everything. Yeah. So we used that as a starting point, redeveloped slides. We decided to do a material science lecture on Monday, an archaeology lecture on Wednesday, and then have a flipped classroom with teams on Friday. And as we got into it, and talked, and then as we moved into a real place and could actually be there live, even though our students didn't show up, it was really fun because, I learned things about the Bronze Age that I never knew. I learned things about extractive metallurgy that we used to teach in our departments, and we don't teach that stuff anymore, but especially things like the Bronze Age. How the original bronze was all arsenic bronze because in Turkey, they had lots of naturally occurring deposits of copper with arsenic in it. And when they melted those rocks in fires, because they had learned how to build hearths, and they learned how to make, I didn't realize that all the technology for making ceramics came first.
Yeah.
And so making lime and plaster was really important. But then they could throw rocks in there and this copper liquid would come out.
Kilns become furnaces.
Right, and transference. And then hearing you talk about Vulcan, right, who is one of the, the god of fire, but was also the, revered as a bronze maker.
Metalsmith,
And then you told me he was always depicted as a cripple. Because he breathed too much arsenic.
Too much of the fume.
And he, got sick.
Yeah.
And it's just fascinating how even way back then they were grappling with pollution and sickness from things that they were creating, but they didn't know what was going on.
No. We're not. It's like we are smarter and yet more stupid at the same time, because we do know what's going on and still won't, and still do it. Yeah.
Right. And you also, I'm getting a little mixed up here, but there are a lot of things, a lot of myths that I had heard that you totally blew away. Like, why did the Iron Age come about?
Yeah.
You know, I always thought it was because iron made better swords.
so much better.
But it wasn't.
Yeah.
And it turned out something that we learned about all over again in the pandemic, supply chains.
Yeah.
And you were explaining how the supply chains that developed to bring tin to the copper producing areas by using the currency of a goat hide or a ox hide.
The oxhide.
And all these things that archaeologists have discovered really describe this massive supply chain trade routes that had developed.
Yeah.
And so when they got destroyed by, tribes, it took thousands of years to recover from that.
Or hundreds anyway.
At least,
Yeah.
Whereas with the pandemic, it destroyed our supply chain and it knocked us out for like 6 months and we thought we were all going to die.
Yeah. And we didn't even have to contend with the sea peoples.
No, exactly.
Yeah.
Exactly.
So imagine if they had come
Those sea
along again,
peoples.
whoever they were.
Whoever they were. But look, that whole process of how that to me is something that's fascinating. Is looking at how those commodity networks developed, and how you get all of these civilizations. And I use the civilization word that are still familiar with us today. That are still in some ways like going back to classics, right? Kind of the root of Western civ is in this Bronze Age, where you get the Homeric legends from Greece, and you get the Middle Kingdom, New Kingdom Egyptians, and you get the Assyrian Empire, and you get the Hittite Empire, and then all of it crumbles so quickly. And when it does, all those supply chains break down, and all of a sudden people can't get tin. So you've got the option of just using copper, but the copper doesn't work anymore. Not post Bronze Age. Again, with the Bronze Age is the first time we have standing armies that are outfitted with weapons. And before this, it was you're living in primarily towns, villages, and if there's a threat, then everybody who's capable of picking something up to fights with it. The whole idea of having an army that is a standing army, that is a paid army, that is outfitted by, in a sense, the royal family, whoever owns that stuff. Now, we're also looking at that something like bronze, which is just a material, becomes a technology that opens up an entirely new niche, a new technological niche of warfare. Not just the bow and arrow, which people used in warfare before that, but was also the hunting. It was primarily what you used for hunting. You just use the same thing to kill people as you use to kill deer. But the sword, no one's hunting with swords. No one is hunting really with chariots and swords. That's warfare. And when the Bronze Age ends, when the tin is no longer available, people can't just go back to copper, and they're sure not going to go back to stone. A lot of people don't even remember how to make stone tools. So some of the people in some of the more peripheral areas who really don't have access to tin, they start experimenting with different kinds of iron. And raw iron it's hard as hell to use. It's ugly when it comes out. The iron bloom looks terrible. You have to pound it forever to get it turned into anything. But once you learn a couple of tricks just by experimentation, because you have to, not because iron is better than bronze, or you don't know that it's better than bronze. It is, but you don't know that it is yet. But with a few little tricks you learn through experimentation, that iron becomes steel. And all of a sudden, bronze is as passé as you can get now. And then you've got the Romans, right? So it's a fantastic way of looking at the way that contingency, that the technology doesn't evolve in some kind of generalized path from worse technology to better technology. It's all these different contingencies that come into it. Look at the beta and VHS. As part of the. It's not always the best technology that wins out. It's the one that contingently has the cards fall the right way.
Yeah. One of the interesting connections with material science that I think about with the tin problem is that now that we have all of these characterization tools like Steve is talking about, we can do the isotopic analysis, right? And say, oh, did this tin come from Afghanistan, or did it come from Cornwall, or did it come from China? And to help to understand what these trade routes must have looked like based on which isotopic balances of which alloying elements ended up in these bronze artifacts that we find in different places in the world. It's just, it's such a wonderful detective story.
Absolutely.
And it's so cool that we're able to piece these things together.
One of my classmates at Northwestern, Mark Schwartz, he's actually a professor at Grand Valley State now. He's a Middle Eastern, Near Eastern archaeologist, and his dissertation project, we always felt like he got the shaft from his dissertation advisor, because his dissertation data set was the bitumen from the site where his advisor had been working. Other people got the ceramics and the lithics and the some of the the fancier stuff. He got basically
a piece of coal.
he got bags of coal, bags of tar. And we'd want to go out on Friday night. He's like, no, I have to be in the lab. I'm titrating tonight. But he ended up with this dissertation where he was able to use the chemical sourcing to trace the bitumen. And he reconstructed the trade networks using the bitumen in a way that you couldn't have done with the ceramics or the lithics in quite the same way, and ended up as a professor at Grand Valley State. So it's a fantastic dissertation. Yeah, but hitting the same ideas.
Mm-hmm. So listening to what you were just saying, it sure reminds me of things that are very current now. Processing rare earth metals, making NVIDIA chips to dominate the world, making quantum materials to make qubits. The only reason we need quantum computers is for defense, for secrets, for NSA, to make codes that people crack. And so much of our world is being driven by the same things that were driving the world thousands and thousands of years ago. Not hundreds of thousands, but certainly thousands. Once transference did start to come.
Well, and really once, let's just say again that transposing may go way, way back. But what does is it's the Holocene. The Holocene is what changes everything. So that's one other piece of this puzzle that I think is so important, for technology and the rest, is that when you go back before 12,000 years ago, it was literally impossible. Agriculture was impossible prior to 12,000 years ago. And the only domesticated animal on the planet was the dog. There was no domesticated plant on the planet. 14,000 years ago, there were no crackers, there was no wine, there was no cheese, there was no all the stuff that our world depends on now. Not a single one of the domesticated grains that life depends on now. Or people were, every now and then you'd gather some to use as a secondary food when you didn't have anything else available. And along with that, stone was still the most developed technology and material for technology. There were no one was making clay pots, because if everyone is living as a hunter-gatherer and having to walk around in the landscape, clay pots are heavy, and if you drop it, all that work is for nothing, right? It's broken. It was only with 12,000 years or so when the Holocene started, and our climate became stable. Once we had a stable climate in this little bitty window, we go back 2 million years. Homo sapiens sapien goes back 300,000 years. Only 12,000 years ago that we were operating with a stable climate and with all the conceptual tools that our brain had, the language capacity, the capacity for symbolic communication, all that probably came in around 50, 75,000 years or so ago. 12,000 years ago, the climate becomes stable across the whole planet. And when it does, we settle down on the landscape. And when we settle down, our population starts going up. We have to start using more of these plants that become domesticated plants. Wheat, barley, oats, rice, maize, depending on where you are. And we want things to store those in. So we learn how to make clay pots. And we make those in these kilns. And then we go from that to making bronze in those same kilns. And all the technology that has come out of our world, that when we look around the world today, all that is a product of the last 12,000 years, which really, you really think about how special this last 12,000 years have been. We've basically gone over 2 million years living as hunter-gatherers, and then in 12,000 years, a blink of an eye of that 2 million years, we've turned the entire planet into a single artifact, really. From the outermost part of the atmosphere to the deepest parts of the ocean, it's all affected by us. Yeah. Right?
That's fascinating. Mm-hmm. And so that's where sustainability comes in.
Yeah.
Sustainability is a very broad word. And sadly, it means many different things to many different people. Sure, people think about climate, they think about energy, but a lot of people think sustainability is about the sustainability of the biosphere. And we need to really worry about protecting the biosphere. And I happen to believe that that's true, but only because if we don't protect the biosphere, we're going to destroy our civilization. So to me, sustainability is a very modern concept within these last 12,000 years of it's very human-centric.
Yes. Yeah.
Sustainability really only talks about the sustainability of us as human beings, because the Earth is going to be fine. If we were just, we're the biggest threat to the biosphere.
Yes, and one of the things we do, we forget that we are bio, right? That we are part of the biosphere, and I say that. Yet at the same time, 12,000 years ago, any place we walked into for the first time, and we were still populating the planet 12,000, 20,000 years ago. Any place we walked into, we were the apex predator. And any other predator fell by the wayside in comparison to us. And somewhere around 10 to 5,000 years or so, we're no longer the apex predator in any kind of landscape. We are now apart from this landscape in that way. And yet we still depend on it. All of our food comes from that landscape. All of our food comes from, if we include the biosphere as being all biological life, then obviously everything that we have comes out of that biosphere. But there's a big difference between let's call it the human realm biosphere and everything else. Something like, if you take all of the non-domesticated animals on the planet and put them in one scale, and then all of the pigs, goats, sheep, cattle, horses, dogs, and cats put on the other scale. I think it's like 7 different kinds of animals. This one, the domesticated animals, now outweigh all of the non-domesticated animals by a factor of like 5 or 6. Yeah. All right. And this includes whales and elephants and hippopotami, and it's not even close. We have turned the Earth into our zone. And when we think about sustainability, if we look at what sustainability meant, it is a new idea, because it was something that didn't need to be discussed a few thousand years ago. Right. There was no such idea. Right now, sustainability, the way we think about and talk about sustainability, is a lifestyle. 10,000 years ago, sustainability was a stay alive style. Right, because if you're not living sustainably, you're not living. Right, we can live now with the sustainability lifestyle. I recycle my milk cartons and the tin cans that my cat food comes in. I'm a good guy. I wash them out and recycle them, and I'm living sustainably. But that's not sustainable.
Yeah, no, I get it. And what I think people forget about is how quickly nature can repair itself once we're gone. So if we were to vanish, if we were to totally vanish, within 100 years, the Earth would come right back.
Well, it would, and within 1 million years, it would, in a million years, it may not even look like we were here in a lot of ways.
Right. Exactly. On the other hand,
There's a good book about that. It's a short little book, and it's called something like "If We Were Gone." The whole setup of the book is what happens if humans disappeared today. All humans across the whole planet. Now, I'm not saying that's a good thing. I'm not saying we should be working toward humans disappearing. But the book lays out that question. It basically goes through over a span of a year, a decade, 100 years, 1,000 years. What does the world look like without us in it?
right.
And the biology bounces back. There are a few things we could do that would make it all but impossible for biology to bounce back.
So something I think about, I'm curious to hear your opinion on it, is how much of this is a scaling problem? As you mentioned, there was a time when the human population of Europe was 10,000. Yeah. That's very different from 100 million. And so if ancient civilizations, or even I'll just say, pre-industrial revolution civilizations were not concerned with these things, can you extrapolate maybe, or even just make a guess about how their cultural values, right, how their societal processes might have to adapt or change to the scale of 9 billion humans, and what can we learn about the modern age from their way of living?
I find in some ways, so look, a lot of people assume that Native Americans, that they were the original, sustainability culture in a way. Now, on the one hand, that makes the horrible mistake of assuming that all Native Americans acted the same, thought the same, performed the same kinds of acts. But when we think about, again, sustainability in that kind of context, the things you can do and still be living sustainably are different. One of the great examples are the the bison jumps in different parts of what's now the American West, where early Native American groups in the Americas, 12,000, 10,000, 9,000 years or so ago, would basically get a small section of the buffalo herd or the bison herd off and drive them down a chute. They would set stone cairns and things up along this chute that starts out wide, gets narrower and narrower, and there are people along those cairns banging drums, making noise, yelling to keep those bison moving toward a drop-off. And the bison would hit it and just run right over, and you may end up with 30, 40, 50 bison that just pile up at the bottom of that. And the people could then go to that bison jump where those bison have all died or are dying in that big pileup of bison, and they only really need to harvest the meat off the top 10 or so. The ones underneath just rot. Now, that sounds horribly unsustainable and the rest, except that the entire human population of North America at the time was probably, again, a few thousand people. And there were more than 1 million bison in that great herd that stretched from basically the Mississippi to the Rocky Mountains. So they could do that sustainably, and it was a great idea. What we do now with 9 billion people, I'll go back to the idea of biospheres being something that we're not part of. For me, I think it's hard for people to remember that we are animals. And that in a way, this sounds like I'm very anti-human. I'm not. I've got 2 kids who are very human. I love very much. And yet, as a species, we're like the ultimate invasive species. Right? We are. And there is not a single thing on Earth so far over the last, let's be liberal and say over the last 1,000 years, but it's really over the last 200 or 300 years, there's nothing to check us as a species. If you track human population over time and you go back to, let's just go back to Homo sapiens sapien 300,000 years ago and track it as a graph, it's going to look like this gradual. You hit about 1800 and it's through the roof of the building. Right. The scale difference is so big. And not only the scale difference, but also the social life distance. I tell my introduction to archaeology classes right at I think probably near the beginning of class, that if you took someone from 1790 Philadelphia, they are going to understand and will be able to adapt better to life in 4000 BP Uruk than they are Philadelphia in 2025. Right? That much has changed. Life in Philadelphia in 1790 was more like life in Uruk 6,000 years ago than life in Philadelphia 1790 was like life in Philadelphia today.
But of course, this is because we've learned how to control disease. We've learned how to produce lots of food.
Phosphate fertilizers.
Yes. And, the story I think I told you about that book, The Alchemy of Air,
Yeah.
which is the Haber-Bosch story, because in the late 1800s, the Royal Society announced to the world that there was going to be massive famine in the 1930s and 1940s because they used up all the arable land across the whole planet. And they already fought wars over guano. And they already used it all up, so it didn't even matter who won. And they were facing a situation that had already happened probably before. There were many examples of famine, and that was a common thing because people weren't able to move very far to find new land and then transport food back. So famine checked humans quite a bit until we learned how to break apart the nitrogen in air with high pressure, high temperature catalysis. And that's what keeps us all alive today.
It is.
Still.
It is.
And it's also what is 10% of the man-made CO2 load on the atmosphere is the hydrogen reforming to make the hydrogen for that process.
And that brings up another aspect that maybe it's connected to sustainability. Because again, and this is one of the things I think archaeology gives us. When we think about why does the world look the way it does today, and thinking about archaeology that way, you have to have the time depth that you can't get from written records, that you don't get just from history. And one of the things that you see when you look at the Greenland ice cores, which go back for a couple 100,000 years, of looking at climate over this really deep, long period of time, is that all through this, so basically the Pleistocene is the last ice age, is the last period of glaciations. If we were in Michigan 15,000 years ago, where we were sitting right now, the ice was a mile high. Not 100 feet or 200 feet of ice, a mile high ice. Weighed so much that as it retreated, it carved out the Great Lakes. Right? So that's how much ice we're talking about. And that's the way most of the last 200,000 years or so, 250,000 years, maybe more, maybe a million years, but that's what it looked like. We can only trace it to the Greenland ice cores back a couple 100,000 years or so. But we find that every 100,000 years, or every 50,000 years or so, there's this little period of time. There's a blip of time, 10 to 12,000 years or so, when the climate stabilizes. See, that's if you look at this periods between ice age, if you look at the periods during the ice ages, the climate looks like this. You literally cannot predict one year to the next. You don't know, you could never know when to plant, when to harvest, what's going to grow, what's not going to grow. It's impossible to predict anything, which is why people lived as hunter-gatherers that whole time and had low populations in sustainability with the environment around them. But then when you get these periods between ice ages, which are called interstitials, the climate stabilizes. And instead of looking like this, for a few thousand years it looks like this. But then it goes back into this again. All right? So what we are living in right now, the Holocene, is one of those interstitials. It's a 12,000 year period where the climate has stabilized. But it's the first one of these in the history of the world, or in the history of the ice ages anyway, let's say, where there was a mammal, a bipedal mammal, with our symbolic capacity for thought and technology. The last time there was one of these, we don't seem to have had that full suite of symbolic thought and language.
Right, the combination of knowledge, technology, social structure.
Exactly. This is the first time. Okay. So that's great. That explains why it all happened during this interstitial and not a previous interstitial. But if this is an interstitial, We are in climate change right now. Everyone talks about, is this the Anthropocene? Have we left the Holocene and entered a new climate regime? Well, everything in the world around us, and it's 9 billion people, the cities, how many of us produce our own food? I ask my classes that as well. You may grow some heirloom tomatoes, you may grow some basil out on your windowsill, but how many of you grow your own food? How many of you know anybody who grows your food, right? I thought that whole idea of having cities of 20 million people where no one in that place makes their own food, what happens if the Holocene is no longer relevant? We're not talking about that. We're talking about changing we're talking about changing emissions and switching from, some of us were talking about switching from gas-powered to electric-powered, which are conversations we should be having. But there's some aspect of this that is, from what we can see over the last few 100,000 years anyway, is that there are these cyclical patterns in the Earth's climate. And these 12,000-year-long interstitials are a part of that. If the Holocene doesn't pertain anymore, we need to be talking about how we're going to sustain in this next climate regime, whatever it looks like. And that's a whole other conversation. Not just for us, but for us as a species, really.
Yeah. To bring it back to the class a little bit before we wrap up, certainly as the global climate does whatever it does next, solutions to this can't be purely technological, right? It's going to have to be a mixture of technological innovation, societal changes, individual behavioral changes. Yeah. All of these things will need to happen if we're going to survive as a species. Yeah. So given that, education, of course, we're all congratulating ourselves here, but education will be part of the solution. But I really do believe that. And so when we have classes that, for example, bring anthropology, archaeology students together with engineers, this is going to create students who are better able to engage in dialogue about these kinds of complicated problems.
I think so. I think it's for both sides. Not, for engineers getting an exposure to the social science aspect, but also for folks on the social science side to get a perspective on the engineering side of things. I think it's a great back and forth.
Yeah. So what have you seen in terms of outcomes for your students in your department? Are they engaging in new ideas differently? Are you getting more students from maybe like the physical sciences who are more interested in what you're doing? What are you getting out of it?
I think that those students, those of our archaeology students who have taken the course, really got a lot out of it. And I think it actually helped them as they're developing letters for grad school and developing their statements for grad school. Having that perspective in the materials science, I had none of this either. I've learned so much from listening to Steve's lectures on all of these materials. I think it's been easier for people to see how these two things go together in ways they didn't think about it going together before. I think for there to be that kind of programmatic changes, I think the class needs to go longer. I think it takes longer time than just the 4 to 5 years that Steve and I have taught the class for it to really have those kind of programmatic impacts.
And I think it goes even deeper than that. I think from what I at least have learned in teaching this class, it makes me think I've been teaching intro to materials at the higher level all wrong because it's so dry what I do. Here's the crystal structures. Here's how you do directions and planes. Here's the, diffusion equation, and here's how you solve it. And
I like how you can just read Callister out loud from memory now.
Well, yeah. But the point is, wouldn't it be better if we told great stories along the way of why that's important and teach it in a mode where we take advantage of transposing? To say, here's what we learned about crystal structure. How do we use this? Yeah. Give us some examples of why understanding crystal structure, say perovskites, why, when we recognize all that space in there, it's kind of nature's garbage bag. You can throw anything in there. And this is how we develop perovskite solar cells, which are now the cutting edge technology. It's not there yet. Silicon's still better. But talk about it in the context of how we're going to use these fundamentals, which are the real core things we're trying to teach the students. But make sure everything we're teaching the student has this connection to reality and even hope.
Yeah.
Because we don't know if these are going to work, but we do know that the only way we're going to get there is by transposing the ideas we've developed. Because that's how we know it's going to work that way.
Yeah, and there's no such thing as invention. Okay? Everything that exists is something that is derived from something that existed before it, right? And the microphone you're holding in your hand, the cameras that we're looking into, as crazy as it sounds, actually trace back to the pebble tools that our Homo habilis ancestors were knocking together in Oldowan Gorge 2 million years ago. There is a lineal descent from those tools to these cameras. And it's by continually transposing new schemes, new ideas in. You mentioned the idea of story and how important story is to be telling with these. That's also something, and it probably goes back to people around the first fires 1 million years ago. This idea of narrative, right? So when you put together a class like ours, where each week we covered a different material. So we went from like ceramics and copper and glass, bronze, to concrete, we had iron, we had all the way up to silicon and semiconductors.
Yes.
Now, you can arrange those, you could arrange them alphabetically. And that's one way of organizing the class that is completely, entirely non-narrative. There's no story in that at all. And actually, one of the things I think we did differently from the way the class was originally organized, the way the Florida folks did it was that Kevin taught the material science part of the course, and that he had guest speakers come in to handle each of the different materials from a social science perspective. So there were sociologists and historians and classical archaeologists and anthropological archaeologists all the way through. But it also meant that on that social science side, there was no narrative from the beginning of the course to the end. And so the way we did it with one material scientist and one social scientist, archaeologist, there could be narrative on both sides. And it actually made sense at that point to organize the class around the idea of time. So we really started with the earliest kinds of materials that we used and worked through the more recent forms like aluminum, which I didn't know really didn't exist until the 1850s. Yeah.
And plastics.
And plastics.
But they did exist, just natural.
Natural, exactly. So, and the polymers, and using the talking about polymers that way, natural polymers versus inorganic polymers. I think the way we organized the class is one of the things that made it most interesting for the students in it.
Right. But I almost think that if we use that same organization, but taught it in the context of intro to materials for engineers, that would add so much more depth and interest. And I think what got me was the student came by my office. He's a engineering physics sophomore. And he was referred to me from people at our Zeus facility because he wanted to know how to use ultrafast lasers for materials. And so I started, telling him the research I'm doing, and it all went back to the same, because everything I've done in my research career is use those fundamental concepts of, structure, property, processing, performance, and crystal structure and mass transport and interaction of energy with materials, how things are bonded. And so I started explaining why all this stuff works. And more importantly, that just like archaeology spans millions of years, if you go the other way and look at millionths of seconds or millionths of seconds and look at different processes that happen on those very short time scales, and if you honor those time scales and recognize some things happen quickly, other things take much longer, so all of a sudden you have a sequence of events that makes it much richer. And so I'm explaining all this, and he turns to me and he says, oh my God, this is amazing. This is so, we taught for 3 hours.
Wow.
And he goes, this is amazing. He goes, why was my intro to materials course so boring? And I'm thinking like, oh my God, that's my fault. And so it made me realize that we need really to tell these stories, even if it's the story of how electrons interact and how that leads to coupling back with a lattice to then
Telling
things
them
start
as stories.
as stories is so important. And it's funny, we did that whole talk at that virtual conference on the importance of social learning, because that was the call was because it was perusal. And Perusal feels that they found a way to read a book more socially as a team, as a group. So they wanted people to write about social learning. And I turned to Rob and going like, oh my God, everything I've learned from you is how humans have been doing social learning since 3 million years ago. And they sat around a campfire and told stories. That's how we're teaching our course. So we did a whole 15-minute video about why social learning taps into that primal part of our brain.
Well, and we have this idea, even when a little kid tells a lie, it's like, oh, you should stop telling those stories. Where story equates with something not true, right? You can tell fictional stories, but you can't tell us a nonfiction story, or somehow that the story aspect is less valid in some way than the scientific aspect. But stories are the best way to learn.
Well, and on top of that, again, respecting timescales.
Yeah.
People have taught other generations how to do things with an oral tradition through telling stories for millions of years. And that is hard baked in our DNA. And as I learned from you, writing didn't show up till 5,000 or 10,000 years ago. So this formal academic thing just hasn't been around long enough to touch our DNA.
No.
So why aren't we tapping into our superhuman strengths, which is how our DNA has evolved? Those are the things we need to tap into if we really want to teach people. And so I just, I learned that from you in archaeology. So it's been really cool.
Yeah. Since you brought up writing, before we wrap up, this is already getting to be a long story in and of itself. But one of the icebreakers I do first day of class for a lot of my classes is just, what do you think is the most important technology ever invented? And of course, people say, oh, the wheel, the fire, whatever. And nobody ever says the answer I really want. And so then when it's my turn, I'm like, writing. Now, of course, there's not a correct answer to this question, but just to get students to realize that technology does not necessarily mean machines with moving parts and control of physical and chemical principles. There are a lot of cognitive technologies that we've invented as well. Storytelling, memorization principles, like how did people remember epics, right? Like the Epic of Gilgamesh or the Mahabharata or the Iliad for that matter before they were written down.
Well, this is one of the great ways, this is, so I want to two parts of that. It'll be like a two-part kind of response. The first one is like things like the Iliad and the Odyssey. How did people remember those? I ask my, probably before we get to writing, but not too much before that, but I'll ask in my Intro to Archaeology courses, how many of you can recite a poem from memory of more than 4 stanzas or so? And I'll get, 1 or 2 hands will go up. People remember like the first lines of like the Raven or something like that. But then I ask a separate question. How many of you know the lyrics to at least 10 songs? Right? Our brain is cued. If you put it to music, if you put the information to music, we remember it almost infinitely. All of us know hundreds and hundreds of songs. When it's Christmas time, how many just Christmas time songs can you sing along with? When someone, but if those were just poems, we couldn't do it. Right. So music is a kind of technological, and we actually see when the first musical instruments show up about 50,000 years ago. These bone flutes that show up in caves in Europe around 50,000 or so years ago. And when I think of what we use language for, and why we have language. That's one of the biggest questions that's still hanging out there. Why do we have language? What did it come from? That's one more thing. I have a hard time separating it from technology, because as technology becomes more and more complex, we need more and more complex words and phrases to describe what we're doing and what we're using. It's one thing to pick up a cobble and knock two flakes off to make a sharp edge, but when you're making a very delicate projectile point this long off of a chert blade or a flint blade, describing to someone the different tools you're using to make this blade and the different processes you're doing and the different steps you're taking, it's all about operational chains. And I actually think that operational chains are essential to this core. And really, when we're talking about transposing schemas and technology, we're talking about taking part of this operational chain and putting it into this other operational chain over here. Writing is something that eventually becomes, writing didn't start out in almost any part of the world as being related to technology. But as soon as people realize that not only can I use this writing to record how many baskets of fruit came in from this people that owe us fruit, or how long these kings served as king or had the office of king, but I can write down how I'm making this bronze and write down this process of making the mold for the bronze sword and the rest. Okay, now you've got the new vehicle. You can have more complex technology than what we can just remember those operational chains in our head. So it becomes an external form for maintaining operational chains. And we do that for a few thousand years before we get to this, okay, now we're not even analog anymore, right? In terms of how we're maintaining operational chains that we may not even have a step in the process of production anymore. So thinking about what's the most important technology, I would say in some ways the most important technology is the first one, because I really do believe that these operational chains evolve, and that you can't get the smartphone until you've had that first step of someone showing someone else, someone that's, you can imagine two Homo habilis, actually we know it's prior to Homo habilis now, but you can imagine two of our hominid ancestors sitting around, and one of them has a sharp flake that they've made, and they're cutting meat off a bone. They're scurrying out on the savannah. They're scurrying out from under their trees to a dead antelope that a lion has brought down, and the lion has left the rest of the carcass, and they're going to scurry out there and try to get some meat off the carcass before scurrying back to the trees, before the hyenas and jackals show up, that they still can't really defeat. They're not strong enough to actually beat those animals off. So they're going to scurry out there, and one of them is just trying with his hands to rip some meat off. The other one has a sharp edge on this tool. He's using this to hack the meat off. And the guy's like, in one way or another, how did you make that? They didn't have the same language for it, but as soon as that person can show, smack it with the other rock, and you've got your sharp edge. That an operational chain was just created and passed from one person to another person, and that is that's a huge thing.
So basically, education.
Education. There you go.
Most
It all goes back to
important
education.
invention.
Yes, that's the first PhD was the one who showed how to make the sharp flake.
That's great. Well, how long have we been going for now?
A minute. We should probably wrap up.
Yeah, so this has been absolutely fascinating.
I don't get to see you every week now. So.
Yeah, well, this is, we could have spent, you didn't even tell us about King Tut's dagger and where iron came from, or how Damascus steel didn't come from Damascus, it came from India, and how these apocryphal stories of quenching blades into slaves, which was absurd. And we also didn't get to talk about, Tim runs a whole blacksmithing club, which right. Your students are welcome to join.
And you get to talk about pouring aluminum, which is one of the most fun things that our archaeology students loved getting to.
So maybe we should have a whole nother podcast on other fun things. And hopefully this course will continue. Tim's very interested, so when we're done, we should talk about how to make it continue. And I really think we should reinvent the way we teach intro to materials, to have this story component to it, because I've learned so much by teaching this course with you. It has been the most fun thing I've ever done as an academic. So it's been great.
I've had fun with it too. Yeah, thank you.
Anyway, we always like to end up, is there anything you'd like to say to pitch something that is important to you? We'll be having show notes, so hopefully you'll give us links, because you're the curator for this anthropological, the UMA or whatever it's called, UMA. And so we'd like to put some links into the show notes for that, to maybe some of your research and whatever else you'd like.
Yeah.
But is there anything you'd like to add?
I would say, just in terms of research stuff, we had a really nice article that was in the LSA magazine this past spring on the Cahokia project. One of the things that makes the project, I think, interesting, and also that makes it special, is that we are working in collaboration with the Native American tribes, who consider Cahokia to be their place of origin. They're one of the places where they built. It's their ancestors who built it, who lived there, who died there, who were buried there. And we're trying to work with them in terms of how we handle the data, how we share the data, so I think that collaboration has been really powerful. There's a story about it in the LSA magazine. And I'd say, again, in terms of the new UMA, which is going to be, again, this big new archaeology center to keep your eyes open. We'll hopefully be having some announcements about it over the next few months.
Excellent. Well, Rob, it's been a true delight to have you on the show. I'm glad we finally got to make this connection.
Thank you guys so much. It's been a pleasure to sit here and talk.
All right. And for everyone else out there, as always, we'll see you on the next episode of Undercooled.
See you later.